So now it's time for something a little different. I'm not a scientist at all, but I work with some really smart people, and we hire scientists, which is the good news. I work for the Milwaukee Metropolitan Sewerage District, where I'm the manager of sustainability there. And I'm going to give you one slide infomercial on MMSD, where I work, a little bit about the regional context, and then what it is we do in terms of adaptation and mitigation, and then finally end with a slide that has some resource links for you. So if you can imagine the state of Wisconsin, which you've seen up here a number of times already today, we're in the southeast corner, right along Lake Michigan. This is a map of the region that we serve. It's a little hard to see, but there's a gold line that covers all or part of 28 municipalities. The largest by far is the city of Milwaukee, but we do cover 27 other municipalities with a total area of 411 square miles. At our very core, we convey, treat, and store wastewater, not necessarily in that order. But we do a lot of other things as well. And we do those other things because stormwater doesn't exist in a vacuum. I mean, not stormwater, wastewater doesn't exist in a vacuum. Stormwater gets into it. When we have out-of-bank flooding, we can sometimes have water pouring into our system. So stormwater, stream water, and wastewater can occasionally commingle. And so it's in our best interest to work with and throughout the region with our 28 municipalities who have their own individual systems to make sure that we protect the environment to the extent that we can. And the end result of all of this work, and there's been a lot of work done, has been a resurgence in downtown Milwaukee over the past 10 or 15 years or so, where restaurants used to turn their backs to the river. The restaurants and bars now have a lot of outdoor seating. There's a river walk that's heavily populated, particularly at lunch hour. It's just a lovely place to be. But of course, there's still always work to do. And part of the work, or part of the challenge that we're facing, are the changes that we have been seeing over a number of decades in weather patterns. And so this morning we heard about an effort called Wiki, or the Wisconsin Initiative on Climate Change Impacts. This is just one page from what I used to call the Wiki Report, but when I went online, I realized there are like dozens of Wiki Reports now. So this is from one of the Wiki Reports, but maybe about 4 years ago or so. And if you're going to do any reporting in Wisconsin, or you're just looking for ideas, this is a great resource, because each issue that's tackled in this report is tackled in half a page, maximum 2 to 3 pages probably. It's very approachable, but written by scientists, and heavily conveys the depth that someone would need to understand in order to get the picture. So then, coming down to an even smaller scale, I like to use local data when I talk to audiences. This is one example. It's a slide that's a few years old, so I culled this data maybe 3 years ago. But it tells a really interesting story of the Kinnickinnick River watershed, which is a watershed in mostly in the city of Milwaukee. It's very heavily urbanized. It's rather small. Much of it is concrete lined, although we do work to take concrete lining out of channels, and we've started to do that in this waterway. And what you see up on the screen is a picture of it during low flow conditions. It looks pretty ugly right there, I imagine. And then a picture during a heavy rainstorm where that water's actually smashing up against a bridge, which has since been replaced, fortunately. We have about a 35 or more year period of record there. So, you know, a pretty sizable number of years to look at. And what I did was I went back and looked at the river crest data. That's over any given day, how high did the water actually flow? And that's in response typically to storms in a short stream like this. And if you look at the years associated with this data, keeping in mind that there's a 35-year period of record, I used to be able to say that 4 of the top 5 peak years had an event in the past 5 of the 35 years, meaning I don't know if this is indicative of climate change, but this is indicative of something that's a more recent phenomenon than had occurred in the past. So the outlier there is 1986. I didn't live in Milwaukee, but that must have been a really interesting storm. So in response to issues like this, MMSD has created some high-level strategic objectives related to integrated watershed management and climate change, mitigation, and adaptation with an emphasis on energy, but not necessarily all about energy. And so I'm going to focus on things that we do related to the second set of strategic objectives for the most part. This is a graphic from our sustainability plan that you can find on the MMSD website. It's meant to just summarize the types of mitigation and adaptation activities that we undertake. We don't undertake everything we do with the big banner of climate change in front of it, but a lot of what we do fits in nicely to what's needed and has to be done. So in terms of mitigation, we have sought to reduce our carbon emissions and also to purchase what we call green seams properties. We actually purchased over 2,600 acres of green seams properties that can act as carbon sinks. In terms of adaptation, we have a number of green infrastructure demonstration projects. I'm just not going through all of this. And then we also look at a lot of design issues. So issues that we face, you've been hearing this time and time again throughout the day, but these increasingly large storms that we have been seeing are a problem. When we have a certain design storm, the sewer pipe doesn't expand for these surprise larger storms. There's not suddenly more capacity. And just like the parking lot at the mall that you don't design for the day after Thanksgiving or Black Friday, you don't design the sewer system typically for the largest storm you can imagine ever seeing, in part because of cost, but also because there will always be another big storm coming, and that one may be bigger. We also are seeing these longer periods of drought in between storms, and we've heard the kind of effects that can have on other parts of the region. And then we have more precipitation falling as rain on frozen ground, and that's what we expect to continue to see. And there are plenty of other issues that we don't have time to go into. So some of the more obvious things that we do to adapt to these changes in precipitation patterns are we build more green infrastructure to infiltrate, hold, and evapotranspire the stormwater that falls. That helps to keep it out of our system, and it helps to keep it out of area rivers that could cause downstream flooding. We have a very active flood management program. We build in, for instance, on levees and flood walls, we build in a 3 feet of freeboard, meaning extra, but that extra will be eroded, not only with more impervious cover, but with bigger storms that it wasn't designed for. So it's important for us to try to build green infrastructure like this bioretention facility that you see at Bradford Beach that helps to hold water where it falls so that it doesn't run off and join massive flows that can either overwhelm area waterways or get into the MMSD system. We're also looking at infrastructure design issues. Part of that is green infrastructure. Part of that in the future may be the sizing of the pipes. There are all kinds of things to consider. But if you think about it, at least in our region, we had been using a 64.5-year period of record for storms. And that period of record had a number of decades back in the, say 40s with lots of much more dry conditions than we experience now. And so when you average in some decades of lesser storms, you come out with a design storm that may not be reflective of current conditions, and that's kind of what we're seeing now. And then we undertake studies to see where we should go, and I think I've got some of that on another slide. Actually, I don't. So let me just talk about a couple. We have worked with some of the folks from Wiki to downscale the statistical manner, not the dynamic manner, some of the global climate models. And then in the global climate models, the pixel size was the size of the state of Wisconsin. So we weren't getting that sort of variability you would hope for. So we, excuse me, I have a cold. We worked with some of the folks from Wiki and downscaled the model, and first did a study to see what the impact would be on our overflows. And there was, as you can imagine, a range of impacts. We have on average 2.3 combined sewer overflows a year. We wanted to see what that would do to the frequency and volumes of overflows, and it really depended quite to a large extent on what global climate model you were using. We took that a step further, and we're about to come out with a study, perhaps this fall, hopefully before winter, that is a vulnerability analysis. It sounds very similar to the methodology that was used for the forest discussion. But we looked at, what would happen if lake levels were to drop, for instance. And I think I've got that coming up. Yep. So imagine, so we heard 2013 was a very low, if not the lowest on record, level for Lake Michigan. We looked at what would happen if that trend were to continue using some of the middle climate scenarios. And we found that there was a threshold at which that would be a problem. We have 2 water reclamation facilities. One of them is rather old. It was built in 1926. It's built on wood piles on an island. So, now we use steel piles. Wood piles work great as long as they're kept wet. And so in the case of falling lake levels, if the lake levels were to fall low enough, then some facilities at our Jones Island water reclamation facility could be imperiled. And so that's something that goes on our watch list that we have to just be aware of. We also know that drought can drop groundwater levels. So if we have these increasingly severe storms with longer periods of drought in between, we could have lower groundwater levels. That could mean less water seeking its way into municipal sewer systems and ultimately into our sewer system. Our sewer system primarily relies on gravity. So if there's less water and we have this really long extended drought, you can imagine less water moving more slowly through the pipes. What that adds up to could be potentially an odor problem, H2S. So what we need to do is continue to track how these precipitation patterns are happening and to try to anticipate where in the system these odor problems may occur, because you can imagine nobody likes to live near an odor problem. So it's something we need to try to get in front of rather than react to. And then finally, these really large storms that we're seeing, they help to define floodplains. We have as a mission to remove all homes within the 1% probability flood, and that's always fun to try to explain to people why the 1% flood is happening, every few years. But when we remove these homes, we either physically remove the home, or we build upstream detention, or we build levees and flood walls, or any combination of those things. If the floodplain were to expand, then the investments that we've made would not be enough, and we'd have to go back and do more work. So besides adaptation, we also do mitigation work. We're very interested in renewable energy projects. We have for a long time anaerobically digested our biosolids at one of our reclamation facilities. And when, in a good year, that can meet about 2/3 of the power needs at that plant, which is pretty significant. We also more recently built a landfill gas pipeline from a landfill, I think it's about from 17 or 19 miles away, to our facility. And that's beginning to power the Jones Island water reclamation facility. So to me, that's very interesting. Our long-term goal is to get off the grid. So to be net zero, we would always still need backup power of some sort during large storms or during some potential failure. But the idea is to be a net zero facility, and I think that we can do that at some point. We also use green infrastructure to sequester carbon, and I already mentioned our Green Seams program. That's the primary thing that we do, but we have purchased 2,600 acres of property that we turn back to local land trusts or municipalities to maintain as forever open space and to maintain as passive use, limited access type land. I think that will be something that generations in the future will be very glad for. And then finally, we've done some work to identify our own carbon footprint, and we're in the process of hiring someone to help us set up a tracking system so that we can track our progress toward our 2035 goal. In this realm, it's reducing our carbon footprint from our 2005 baseline to 2035 by 90%, which is pretty significant, but the use of renewable energy will certainly help us get there. I just wanted to talk a little bit about the trade-offs sometimes that we face, and this is my really bad attempt at a diagram, I'm sorry. But it's meant to show, the red part is meant to show renewable energy. We want to crescendo up to being 100% net renewable. And the blue is meant to show our energy conservation. We want to go from, being wherever we are down to conserving as much as possible. But there are going to be these blips, and I just put one blip in there to show you an example. We're looking, for instance, at high rate treatment. High rate treatment would help us during excessively large storms to treat the large flows that tend to come to us. And if we are able to treat those at a high rate, then we can get more capacity through the plant. However, doing that causes us to use more energy, and that would have more of a greenhouse gas emission if we weren't all on renewables. So there are always going to be these little blips. I'm almost done. And so this, I think, yep, that's my last slide. These are just some data sources that I reference from time to time. The first one is the USGS's water data. That's where I got the river crest height data from, but they also have all kinds of water quality data and groundwater data. The second is where you can go to find all of the Wiki reports. The third is part of our MMSD Green Infrastructure program is called Fresh Coast 740. We have this very large, audacious goal of adding 740 million gallons of green infrastructure capacity. That's larger than the capacity of our tunnel system, so it's no small thing. But you can learn more about that at that site. The National Association of Clean Water folks, they have a climate change guide, as does US EPA has one for water security, so people in water and wastewater. And then finally, we have a sustainability plan that has a whole chapter dedicated to climate change. And just a little side note, when we released that 2 years ago, I got a call from somebody, an acquaintance I know in the community, and he said, "I can't believe you use the phrase climate change publicly. Aren't you government?" And I said, well, we have to call a spade, and our commission is not afraid of using the phrase climate change, and so we were able to do that. And that's all I have. I think we're going to take questions at the end, so let's pass it on.